Okay, this is question 2 in the vectors homework, and in this question we've got two helicopters P and Q moving in the same horizontal plane. That means there's no vertical component. They're modelled as particles moving in straight lines with constant speeds. At noon, P is at the point with position vector 20i plus 35j with respect to fixed origin O. At time t hours afternoon, the position vector of P is p kilometers. When t is a half, the position vector of P is 50i minus 25j kilometers, and we've asked to find the velocity of P in the form of ai plus bj and an expression for P in terms of t. Okay, so to get going on this, we'll express this problem in a diagram, and the diagram looks something like this. So the first helicopter is here at noon with a position vector of 20i plus 35j. Then at t equals a half, the position vector is 50i minus 25j. So conceptually it looks something like this. Okay, we're asked to find the velocity of the helicopter P as it moves along this way, and we know for part A, we know that the velocity is equal to the change in displacement divided by the time with which that displacement changes. Change in displacement is the final displacement minus the initial displacement, so that's the final displacement minus the initial displacement divided by the time. And the final displacement is 50i minus 25j minus the initial displacement, which is 20i plus 35j divided by the time, which is 1/2. So now just sort this out. So 50i minus 20i gets me 30i. I've got minus 25 minus 35, which is minus 60j divided by 1/2, and multiply top and bottom by 2 to get 60i minus 120j kilometers per hour. Okay, then the next part of the question, let me just put the question up here just to refresh. So the next part of the question was to find an expression for P in terms of t. So basically we started up over here at noon, and as time progresses we move along here and we get a new position vector for each time, and at t equals a half, for example, we're down here. So to get the new position vector, say any one of these lines, it's the same as coming up this way and coming down here for the respective distance. So our position vector P, this is in part B, our position vector P is going to be the initial displacement, which is 20i plus 35j, plus the additional displacement that we have, which is basically going to be the velocity times time, which is going to be 60i minus 120j times time. So expand the brackets out here and then bring all the like terms together, which is the I components and the j components, gives us 20 plus 60 times t times I plus 35 minus 120 times t times j. Okay, for the second part of this question, at noon Q is at O, so it's at the origin. At time t hours after noon, the position vector of Q is q kilometers, and the velocity of Q has a magnitude of 120 kilometers per hour in the direction of 4i minus 3j. Find an expression for Q, the displacement, in terms of t. So we've got the direction of the particle, and we've got its speed. So we need to convert the speed and the direction into a velocity vector. And again, let's think about this in terms of a diagram. And so basically Q starts off at the origin, at time t, and it's moving with a velocity vector in this direction, 4I minus 3j. And particle p is doing what we did, or what we saw in the first part of the question, starting up over here at 20I plus 35j, and it's got a velocity vector taking us down this way, and we've got the position vector which we calculated in the first part of the question. So coming back to q, and what we're after is the vector q down this way in terms of a velocity vector. And so the first thing we're going to look at is we're going to look at the unit vector for q, or for the velocity of q. So the unit vector for the velocity of q is going to be 4I minus 3j divided by the modulus of 4I minus 3j. Now this is just a 3, 4, 5 triangle, so 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, the square root of that is 5. So we can now think of a vector looking like this, which is now going to be the unit vector, so divided by 5, or 1/5 of 4I minus 3j. So this is a vector in the direction that we're after, 4I minus 3j, with a modulus of 1. So 1/5 times the size of this, 5, gets me a modulus of 1. Now our particle q has got a velocity of 120, so the velocity vector is going to be 120 times this vector in the direction, or this unit vector in the direction that we're traveling. So 120 divided by 5, 5 into 12 is 2, carry the 2, so it's going to be 24 times 4I minus 3j, so kilometers per hour. Okay, now we're after an expression for q for the position vector, and q is the displacement, so the displacement is just going to be the velocity times time. So finally we can just simply say that our position vector q is going to be 24 times 4I minus 3j times time in terms of kilometers. So there's our position vector for q. Okay, now the next part of the question says find the distance to the nearest kilometre between p and q when t equals 2. Well, now we've got two expressions for both p and q. So we've got the position vector for p. Maybe I should do that as a small p to show it's the position vector. So there's the position vector for p and the position vector for q, and simply all we're going to do is substitute t equals 2 into both of these and then look at the distance using Pythagoras. So at or from p at t equals 2, we're going to get the displacement vector for p is going to be 20 plus 60 times 2 times I plus 35 minus 120 times 2 times j. So we've got 120 here plus 20, so that's going to be 140 times I, and 240 minus 240 plus 35 is going to be 205, or minus 205, so minus 205 times j. So there's a position vector for p. We get this. We do the same for q. We'll get the position vector for q. So from q at t equals 2, our position vector is going to be equal to 24 times 4I minus 3j times 2, and so what do we get there? So we get 192 times I minus 144 times j. Okay, so basically now the distance in the x direction is 140 minus 192. The distance in the y direction is 205 minus 144. So the distance between P and Q is just from Pythagoras. Distance P to Q is going to be 192 minus 140 squared plus 205 minus 144 squared, and the square root of all of that, which is 52 squared plus 61 squared, and the square root of all of that, when we stick it in the calculator, we get 80.16 kilometers, which is approximately equal to 80 kilometers. There's our answer there.